Hello, everybody. I'm Peter Bosch. I'm a distinguished engineer within Cisco's Emerging Technologies and Incubation team. Today, I'm going to be talking about API service reputation scoring for cloud applications, and I'm going to expand the scope a little bit. I'm going to be talking about a few things. First, what is emerging technologies and incubation really? I'm going to be talking about cloud native application security, and I'm going to be specifying I'm going to be detailing some of the functions that go into API reputation scoring and API security. But first, let me touch upon emerging technologies and incubation. I'm a member of that team, and ET&I is about engaging with our partners, our customers, our design partners in novel areas. We do the things that Cisco typically doesn't do, where Cisco's presence is nascent and where we really want to grow. We either want to enhance the technology, we want to solve solutions for our customers, and we would like to do this jointly with our customers so that what we build actually makes sense for our customers. ET&I is a combination of course, emerging technologies and incubation with corporate strategy and a strategic alliances team. So this slide represents how we go about. Basically, we start on the left with hundreds of ideas that go into a funnel. We call that bold bets. Basically, novel ideas where beforehand it's not entirely clear whether they're executable, whether we can make it work, whether they make sense for our customers or not. The key here is to get lots and lots of ideas. In phase two, validation and scope, really what happens is that that funnel makes sure that only a few tens of these bold bet ideas will find their way into a demonstration and a prototype. With that demonstration and a prototype, we can build and sound out whether the solution may actually work. Then we have a process of about 12 months with a go-to-market strategy and a technical viability. Roughly about 5 ideas sit in this phase. And the whole idea in this phase is to jointly work with design partners, selected customers who are willing to experiment jointly with us on some of these new ideas, and to make sure that we actually understand the requirements. But it's also important for the customer, because if we do this right, then you can think of this as bespoke type of application building and tool building and solution building for our customers, which means that the customer will actually get what they want. And then in the last phase, some of these ideas will actually percolate into Cisco, will percolate into a business organization, and from that point onwards, it actually becomes more of traditional Cisco processes. In the next section, I'm going to be talking about application security and API scoring that is part of application security. People often ask, why are we looking at application security? And I often start with this diagram. If you think about traditional network-based security, it really falls in that left bubble. Whereas if you look at cloud-native application security, it falls into that right bubble. The left-hand side is really about making sure that Acme, as a corporation, for their employees, for their run-of-the-mill operations, can protect the people. All of the employees that make use of this of a solution will be protected on the left-hand side. It's very much like I have a series of applications. I run them on an on-prem solution, or I run them in a cloud environment. I put a picket fence around it with a firewall, IDS, IPS, and all of these other very useful tools to protect Acme Inc. On the right-hand side is where we're focusing. On the right-hand side, we're focusing on protecting applications and data. Going forward, we're seeing that lots of companies are transitioning their applications into the cloud, either through a lift and shift or through other means. And the whole idea in this space is to make sure that the application moves from that on-prem solution into a cloud solution. That means that if you're running inside Google or in Azure or in AWS, it becomes a little bit harder to put that picket fence around it. You can set up virtual private clouds to be able to deal with that. But what do you do for those applications that just run natively inside a cloud? And it's really, if we want to protect that, it's really making sure that the application itself has enough means and tools to be able to protect itself. And it's really focusing on the data that the enterprise manages. Imagine that you're building, for instance, an airline. An airline has a series of applications. You would like to run these applications in the cloud. Who's actually protecting that airline application? Who's actually dealing with personal identifiable information? Who's dealing with credit card information, and etc. Because these applications are running in the cloud. So application security is really about making sure that those applications are now secure. It's a busy space, though. There are very many companies in this area, and there are literally hundreds of companies going after this specific space. Yet, if you listen to CNCF, the Cloud Native Computing Foundation, these folks interviewed quite a number of their participants, and they found that security is one of the top challenges in deploying these applications inside the cloud. Complexity, of course, cultural changes, but security is really a solid number 3 of in this space. And it's really about these questions were really asked about your challenges in using or deploying the containers. So we decided to think a little bit out of the box here and think a little bit more cloud native. What we're really after here with cloud native security, application security, is that we would like to protect your cloud native applications. So think about your service mesh with a series of containers, a distributed application. How do you now make sure that you can protect those applications that are completely decomposed and are hosted inside Google Cloud, Azure, AWS? And the key here is that we harmonized on Kubernetes. Kubernetes is, of course, a marvelous technology innovation, but more importantly, it's really also a business game changer. It helps a lot of small companies to get started in this space. It's really a business revolution. And we're seeing two movements. First, new companies that are born in the cloud. And second, companies that have tried to do a lift and shift from their on-prem solutions to virtualized solutions, and then realize that you really need to start rethinking the application to begin with. And interesting for this space as well is that the personas we're interfacing with are not your traditional personas. You really need to work with the developers in such communities, because they are really holding the reins to deploy these applications in the cloud. So what is the problem that we really want to address as we're transitioning into the cloud? The first and foremost issue is that as you're transitioning your application into the cloud, you really start to the first thing you realize is that cloud have different compute and security requirements. I already alluded to the fact that you can't put that picket fence around your solution anymore, which makes it a little bit harder to secure your environment. Now, we've seen DevOps operations whereby operational tasks are handed over to the developer, and really the developer is now using CI/CD tools to make sure that they can manage the operational side of things, the operational side of deploying the applications inside the cloud. But how about DevSecOps? How about these tools that are needed for DevOps folks to make sure that they can actually take on the security issues and observations that exists within cloud applications? If all of the responsibility has moved left, that the developer now needs to do operationals and security, we also need to provide that the tools to the developer to be able to do this. Like I said, CI/CD is there for the developer to do the operational side. We argue that we also need continuous security, continuous testing, and continuous governance tools to be able to enable the developer to execute on these security issues. Developers, by and large, are not well versed in security issues. They lack the tools, but they also lack the knowledge to be able to do this efficiently and effectively. And we really argue that we need to make sure that those security tools are integrated within the developer's tool set. Now we know that first generation cloud application security tools really focus on deployments, infrastructure, vulnerability analysis, and simple attacks. What we now need to be able to build as an industry are tools that actually addresses that CS, CT, and CG gap in that tool set. They need to be the tools need to be able to address more sophisticated attacks. Need to focus on the complexity of the applications. Need to think through architectural soundness, and most importantly, observability and visibility when you're operating in the cloud. The one thing that consistently and continuously comes back when we talk to our partners is that visibility and observability are key. So let me walk you through a before and after use case for developing an application. On the left-hand side is your traditional method for deploying an application. On the right-hand side is what we're arguing. So on the left-hand side, I have three personas. I have a developer, I have a SecOps person, and I have a CISO. The developer's task is to quickly cobble together a solution using all of the assets in their toolset. That can be image libraries, it can be configurations, it can be serverless functions, it can be API services. Why would a developer want to implement all of these tools that they can also get from as a SaaS offering? For instance, if a developer needs to send an SMS, it might just use a SaaS offering that will do that for you instead of having to implement it themselves. But then the problem arises, what can that developer really say about the resources that they're using? And worse, when the developer is done building the application, not unbeknownst to the security vulnerabilities that exists within each of these tools, what can a SecOps person or a SecOps persona say about the application? The SecOps person has no view to the dependencies that the developer has built in their application, and more importantly, will have to do manual scanning to go through all of these assets to make sure that there are no hidden defects in the security defects in the application, which will cost time. And then lastly, a CISO, an information security officer, has no idea what the application is built out of. In other words, they cannot assess what the risks are, cannot show compliance. And again, either there's a lengthy process by going through this very manually, or the CISO can only act retroactively to their customers in case an asset was misused. On the right-hand side is what we argue to do, and it's in essence a very simple concept. What we argue to do is that we keep a database with all of the vulnerabilities, either sourced internally or externally, all of the assets that go into an application, all of the image libraries, configurations, API services, serverless functions that are used for building the application. And then as the developer is building their application for rollout, that developer now has the tools and the means to assess each of these assets, because we have already scored them. We know what these vulnerabilities are. We're going to say this is a no risk issue, this is a low risk issue, and this is a high risk issue. That means that when the developer is done, they can be assured that their application is going to quickly run through the SecOps phase. And as a CISO can now get a complete view to the application and all of the dependencies that are in that application. So what used to cost lots of time can now be done in a series of pipeline cycles going through all the way to actual deployment. Moreover, as a CISO, I can now engage with my customers and I can say, these are all the dependencies and deficiencies that I know of in my application. More importantly, in case a new vulnerability is found through whatever means, we actually learn this through our database. And as a CISO, a CISO is now alerted to the fact that one of their applications may have an issue. That means that as a CISO, I can now be proactive towards my customers. I can say, we're running the following applications. This is the data that you shared with us. These are the vulnerabilities. And as a SecOps person, when I get notified that some asset has been broken, I can now go back to the implementation and start to remediate this and submit a work order for the developer to fix it. Now, needless to say, the developer and the SecOps person can be one person. So these are really personas, which means that now the developer can start to handle all of the issues that may arise from the security aspects. So it's a much smoother process, much faster process, and it will really help accelerate the feature velocity. So really the work that we're after is combining image, metadata, function, API scoring into the development and runtime cycle. It's really a kind of an insurance policy for DevSecOps. One of the first things I'd like to talk a little bit more at depth is about container security. One can argue this is table stakes for cloud native deployments, and rightfully so. It is important to make sure that the applications as these are deployed in cloud infrastructures are not built up out of lots of images and image layers with vulnerabilities embedded in them. So really, the key is this, that as the application is being built inside a CI/CD pipeline, we start to scan configurations and we start to scan images and image libraries before they're deployed. And then as these applications are deployed, you really would like to make sure that you can govern which applications are deployed given certain issues that certain security issues that have been found, that you have a means to continuously verify that the application has not found new vulnerabilities, and more importantly, that as you find new vulnerabilities, that you're not allowing connections to be reestablished between pods and containers that are deemed insecure. The way we do this is depicted on this diagram. On the left, we have a diagram of the kinds of vulnerabilities and attacks that we envisioned. Attacks that are direct from the outside to the container that holds all of the specifics. Then we have lateral attacks that allow you to get into one container before progressing to the one holding all of the interesting information, and lastly through the CI/CD pipeline. So what we do is that we scan Docker images, image layers, packages, dependencies, and all the vulnerabilities that are part of your application before they're deployed. We test Kubernetes configurations. We have role-based access control and cluster activities. We make sure that we track what kind of calls are being made. And then we really have a multi-pronged security enforcement approach. First, early detection and quick mitigation of problems through the CI/CD chain. Then we make sure that we have uniform container internal and external API services with a common security policy enforcement, and I'll touch upon the API services next. But there is a uniform way of dealing with vulnerabilities in containers and internal and external API services. We have automatic traffic encryption for all interactions, even for defunct software. And this may seem like very much table stakes, but often we find that communication interpod or intrapod communication is not even encrypted. And of course, using a PKI for all the computing assets and enabling proper authentication and authorization. And then lastly, as we're deploying and running the application in runtime, we would like to make sure that we have security policy enforcement in CI/CD. You can't deploy the application if they do not adhere to the security policies. During deployment, we test it again by interfacing with Kubernetes. And lastly, on every TCP session or network call that's being established between containers and parts of the application, we test that connection again, and we make sure that the source and destination are still in compliance. The second part of this talk and the title of this talk was really about APIs. So like I said before, container security is important. It's very important to make sure that your application is secure. But more than ever before, applications are relying on third-party services, internal services and external services. We focused on external services first because we thought that this is really kind of important as applications are more dependent on these external services. We realized as we're engaging with design partners like the program is designed to do, that internal services are of course equally important. The it's very easy to understand why developers are starting to use external API services and internal API services. Imagine you go back 20 years, the times that Java was being developed. At that time, there was a booklet about this thick describing all the methods and the classes that accompanied Java, from which you can build your specific applications. Fast forward 3 years, 20 years ago, so 17 years ago, that book was 3 times as thick, printed on very thin paper. There was no programmer who knew all of the methods and the classes that went in there, which also means that there was no developer knowing all of the issues with each of these methods and classes. There can be vulnerabilities in these methods and classes at the time. There can be security flaws. There can be all sorts of issues. So fast forward to where we are now, 20 years later or 17 years later. We believe that we're at exactly that same inflection point for API services. But instead of relying on methods and classes that are linked to your application in the form of a library, we're really dependent on external SaaS offerings, where you have a series of SaaS offerings, services that one can consume. Like I said before, why would a developer implement an SMS service while you can just consume this from an API service? Why would a developer build a graphing tool when you can just consume that from a service? Why would a developer implement their own stack for dealing with credit card transactions? There's an API for that. But the problem is, if you start using those APIs, you're also exposing some of your application, your enterprise application that is run in the cloud now to those third-party services. At a minimum, you may leak some information. The TLS certificate that the third-party service may be using may not be appropriate. The backdoor, you may leave open a backdoor with a buffer overrun issue on the way back. And there's a whole host of issues that are characterized by the OWASP API Top 10 that are known issues. And that's even before you get into the semantic layer. Once I get into layer 7, how do I actually know that the service is properly implemented? That it doesn't expose too much data of me when it communicates with a third-party service? How do I even know that the service I'm communicating with doesn't communicate with on its own with the service? So all of these issues is what we call API and API security. And we really have 2 phases to start to address that. The first phase is about observation. What can we observe from the service? The second phase is really about testing. So imagine that we're building a blue application. Cisco's color is blue, hence the blue application. And let's assume that I'm building a blue application that is relying on a brown service A running on GCP and a green service B on AWS, whereas the blue application is running on Azure. Then there can be many issues with this for the blue service, and let's assume that brown service has an infected image layer. Let's assume that it's not behaving properly. Through various means that I was just saying, maybe through a service mesh, it may spread to the front door. It communicates with the blue service. The blue service may expose data that arrives from customers, and now my customer data is at risk. This is a situation that we would like to avoid. What can we say beforehand of that brown service before we even start using it? So the way we want to do this is quite novel. We build an Oracle, so not the company, but really an Oracle service, a service that is hosted again as a SaaS service of its own, and it observes all of these applications that are publicly addressable. So service A, service B, and whomever else. Once it identifies a risk in any of these services, and that can be based on a number of different things. It can be based on, does that service actually use proper TLS records or certificates? Does it is the site where that service runs hosted on a site that is savory? Is that a site that has been known to distribute malware, or things like does it support HTTP connections over port 80 unencrypted and whatnot? Those are really all the risks that are that can be identified. We report the risk into the blue application, and very simply inside the Blue application, we would remediate the risk. We would make sure that as the Blue application engages with the Brown application, it either blocks it, it reports it to SecOps, it reports it to CISO, or with other means, it can quarantine the interactions between the Blue container communicating with the Brown service. And we want to do this, and we can do this on individual URLs for APIs. We can do this on get, put, delete methods, and we would like to make sure that even within a service. So let's assume that I have a meta service with one for voice and one for SMS. I can actually dissect between the two, and I can score them independently, and I can build a policy inside the Blue application that acts upon that. So that's really step one to the solution. The second step is, of course, how about this layer 7 type of interactions? You can imagine that if I have a Blue application interacting, for instance, with a credit card company as a Brown application, then that interface is contracted over an IDL, an interface definition language. OpenAPI is one of them. gRPC is another one. Simple SOAP XML is a third one, or GraphQL may be there. And really, what can we say about the semantic level of these operations? Can we actually see these messages that are going back and forth? Can we start at the layer 7, start fuzzing that service to better understand if the service is well implemented? Because if these services are poorly implemented, they actually may start leaking information. So what we want to do, what we would like to make sure we do, is that from the Blue service, we observe these interactions as they go back and forth. We observe what PII is being exchanged between those services, and then with the scored information and with our understanding on how that service works, we're going to make sure that we do some form of penetration testing of that service. And in essence, it's a fairly simple process the way we do this. So on one side, in step 1, we learn the service model. We observe these models. We know what kind of interactions are engaged between the Blue application and the Brown application. We know what kind of get, puts, and posts and deletes are being executed on that service. And then once we've learned that, really start crafting a series of tests to make sure that the service behaves the way we expect it to behave. And if it doesn't, maybe that's a good indication that we may want to operate, be a little bit more careful with that service. In other words, what we learned there, we feed back into that Oracle again, and we remediate the interactions with that service. I'd like to call out one very specific thing. Data classification can happen. As we're observing the traffic, we can even say, this actually looks like a social security number. We classify that data, and based on that, we then can put that into our model. So let me stop here on API security. So this last part of this conversation is about serverless functions and serverless containers. Serverless functions are quite interesting. They do not behave the way a typical API service behaves. They really behave quite differently. Rather than doing an RPC, a remote procedure call between a client and the server, in a serverless function, basically you have AWS, for instance, or Google Cloud or Azure, listening to a pub sub bus. And when I post an event to the pub sub bus, what these cloud service providers will do is they will start a virtual machine. Inside that virtual machine, they may start a container. Inside that container, they may start an interpreter, a Python interpreter, for instance, and then will execute your serverless function. But what can you really say about that serverless function? Is that serverless function in itself a risk? Should I do a vulnerability analysis on that serverless function before I deploy it? Akin to what we're doing with images, and for container security, and akin to what we're doing for API security when calling API services. So what we're doing here, and it's a little bit further out, but what we're doing here is that we would like to make sure that we integrate security checks in the CI/CD pipeline. And we make sure that before you deploy these serverless function into the various cloud service providers, they themselves are not exposing or very specific vulnerabilities. Separately, of course, it is important to engage with the CSPs, the cloud service providers, to understand what kind of messaging goes back and forth, so that from a visibility perspective, you're actually getting a good view to what the overall application is doing, including API services and including serverless functions. So today, I've been sharing with you all of the functions that Cisco is executing within ETNI for cloud native application security. But it's of course part of a bigger plan. Cloud native application security really requires you to holistically address issues inside your cloud native applications. So on this diagram, I've put together a few issues that are important for cloud native application security. By and large, this is about DevSecOps tooling. It's really adding the sec to CI/CD. It's really about making sure that CI/CD becomes CI/CD plus continuous security, continuous governance, and continuous testing. And inside that box, we have a series of functional areas that we need. I spoke about container security. I spoke about API reputation and security. I spoke a little bit about API data security and serverless security, and we need application security and CI/CD. This is really the area of infrastructure as code security. Lastly, in cases where you can actually run in-app security, it is important to involve that as well. And of course, these bookends help you make sure that you can do application service identity. Identity is kind of key for these applications. How do you provision keys into your application as a root of trust? And last, but certainly not important, and I dare say even the most important part of this, is that with observability and insights, as a developer now responsible for the operational side and the security part too, I'm actually getting the insights into how my application is operating. There are a few things that are outside this box, things that we always need. Naming, DNS. It's an important part. Network-based security, it remains important, because even though we've been speaking very extensively about cloud-native application security, in some cases you actually may want to tie it back into existing databases that are hosted on-prem. Application and API networking remains important, again, for the same reason. I may want to have to set up a virtual private cloud into your host environment. And we can't do this observability and insights not without network-based insights. Cisco has assets in this space. The industry at large have assets in this space, and you really would like to make sure that you can get access to those infrastructures. That's it for today. I hope I gave you kind of a primer of the types of things that Cisco is doing within ETNI. We can, of course, dig a lot deeper into what this program is all about. For this, please contact your account manager, your account team within Cisco. They'll connect you back to ETNI and to us, and we can have a more in-depth discussion with you going forward. Thank you very much.